Hey, you guys, today we're looking at the concept of gradient, which is on exercise 4D, and it's on page 236 of your textbook. So, you might have heard of the concept of gradient before, whether it's in year 7 or 8, or you might have just heard it in real life. So the gradient of a line is a measure of its slope. Now, in other words, it's how steep a line is, right? So in other words, it's a number that describes how steep the line is, and we can calculate this by considering 2 points and seeing how far it rises and run. So in real life, you need to know about gradient because let's say you're a construction person, right? Let's say you're trying to design a driveway into someone's house. If you design a driveway, so let's say a house is over here, and I've got my amazing drawing. If this is the main road over here, there we go, our main road over here, and the driveway is super steep that the car tries to drive up. This is my terrible drawing of a car, I apologize in advance. The car tries to drive up this way, but it's just going to take too much effort because it's too steep. That means that the gradient's really, really high. And it's going to be very difficult for the car to go up. In another hand, right, if I draw my house or my driveway like this, so let's say my house is over here, and the road's over here. If my driveway is super low gradient, then it might actually end up being so far away that the driveway is super, super long, in which case it's really annoying as well. So we actually apply the idea of gradient in real life. So the gradient, once again, is the steepness or how steep a line is. Okay. Now, the key ideas working with, obviously, gradient. Now, the gradient formula is actually just rise over run. Rise over run. There we go. So we're thinking about how much has it risen divided by how much it's gone. And the gradient can also be positive, negative, 0, or undefined. And I'll go through each of those in a second. With gradient, we always look from left to right. Always left to right. If it's going up as I go from left to right, then it's positive. So in this case, I'm going from left to right. Remember, always look left to right. I am going up as I go to the left. So to the right, sorry. That means it's going to be positive. If I go to the left, from the left to the right, and it goes down, like in this case, then it's going to be negative. For example, if I'm just going to identify this one over here, I know that going from left to right, it's going up as it's going right. So I know that this one's going to be positive. There we go. And I'm looking at this one over here, I can see that as I go from left to right, the gradient's negative because it's going down. If I look over here, you can see that the red line's positive because I'm going from left to right and it's going increasing. And the negative gradient, the blue one, it's going down. But what happens if we have a 0 gradient? Well, the 0 gradient is what happens if we have a perfectly horizontal line. So a 0 gradient, horizontal. In the other hand, if I have an undefined gradient, that's because it is a vertical line. There we go. It's a vertical line. Once again, it's rise over run. So I'm talking about how far has it risen divided by how far it's run. So if I look over here, let's say I pick 2 points that I know, okay? I know this point over here, and I know this point over here. Actually, let's pick this point over here. It doesn't matter which 2 points you pick as long as they're on the line. So I've got those 2 points. Now, this one over here is -1, 0. And this one over here I can see is 2, 6. Okay? So, how far has it run? Well, I know it's gone 1, 2, 3. So, my run equals to 3. And my rise is 1, 2, 3. But it's not actually 3 because if I look at the actual axes, it's gone up by 6. So from there, 6, remember? So from here to there is 6. So my rise is 6. Now remember the formulas, that m, or my gradient, which is the same thing. Don't ask me why m is called a gradient, it's just called m. Rise over run. So it's 6 over 3. In other words, it's 2. So my gradient is actually 2. And you can see that it's actually positive. Positive 2. If I look at the one on the right, I've got a negative gradient. But if I was to try and solve it, Well, I know, well, let's pick 2 points again. So let's pick this one over there and this one over here. How much has it run? Well, I've gone 1, 2. So I've gone to the left. So it's -2. So you can say that the run is -2. I can say that the rise is, well, 1, 2, 3. So that my rise is 3. Using my formula, I know that m equals to rise over 1, so 3 over -2, or -3/2. You can do it that way, or you can identify that it's a negative gradient. So, same thing as before, I know now instead of saying, well, negative or positive, I know that it's gone 2. There's a difference of 2 between this point and this point. Remember, I'm forming a triangle of some sorts. I know that this one is 2 and this one is 3. So rise over 1, m equals to 3/2. But remember, it's a negative gradient. So -3/2. But I do recommend you do it the other way, because that way it works every single time. Okay. Now, what happens if we have a completely horizontal line? Now, with a horizontal line, how much have I risen? Well, 0, right? Because my rise is 0. I'm not increasing at all. So 0. If I pick this point and this point, let's say, it hasn't gone up by anything. So my rise is still 0. But my run, let's say I pick from there to there, then that's 1, 2, 3, 4. So my run equals to 4. So using my gradient formula, remember rise over run, so it's 0/4. If you put 0/4, the answer is 0. So your gradient is 0. Or we can call it a 0 gradient as well. Awesome. Now this one over here, similar idea. Has it risen? Well, yes, let's pick this point and this point here. So 1, 2, 3, let's say that's, I'm just guessing by the way, because there's no actual values on my y-axis, but let's say it's 3. So it's risen 3. Has it run any? Well, no, it hasn't, because it's not moved left or right. So it's 0. My m is going to be 3/0, which if you put in your calculator, comes up as undefined. That's why we get our vertical lines to be an undefined gradient. And so our gradient is undefined. Those are the 4 different types of gradients. Now we can use our formula to find the gradient. So let's do that in this question over here. Find the gradient m of the line joining the given point. So a equals to 3, 4. That's my first point. And my second point is b, 5, 6. What I'm going to do is I'm going to actually just draw those points in. So let's say that's 3, 4. It doesn't actually matter where they are. And let's say this one is 5, 6. I'm going to draw a line between them and then draw some sort of triangle. There we go. It's not perfect, but that'll do. There we go. So I've got the points 5, 6, and 3, 4. Now what happens is I'm trying to find the gradient. So I'm thinking to myself, how far has it run? Okay. So what I'm going to do is I'm going to think about the x value. Because remember, when we're talking about the run, we're talking about left and right. So the distance from here to there is, well, it's 2. 3 to 5, it's 2. It takes 2. To go from 4 to 6, I need 2. So my gradient, m, equals to 2/2, which is 1. Okay. Let's do one more. So over here, I've got -3, 6. So on my graph, -3, 6 would be like over here. And then I've got 1 and -3. So 1, -3 would probably be about there. Okay. Once again, I draw my triangle. There we go. I draw my triangle and I'm going to try and make that look okay. That'll do. Okay, so from there, I'm thinking, well, how far have I gone left or right? I've gone left. So it's originally 1 and I'm going to -3. So I'm going, there's 1, there's 3. So it's -4. Okay, because what I've done is I've used -4 there in order to get a what I've done is I've taken into consideration the 1 there. So it's not going to be 3, it's actually going to be 4. Okay, so from there, what I'm going to do is I'm going to increase. So I'm going to rise. I'm going to go 3, and then there's 6 over here. Okay, 3, 6, that means it gives me 9, and my m is equal to 9 over negative 4. But that's if I'm going to draw it. There's a different way of doing it. Now, the formula for this, I'm going to rub this out. The formula for this is actually y2 minus y1 over x2 minus x1. So m equals to y2 minus y1 over x2 minus x1. You'll use this formula for many years to come. So what I'm going to do is I'm going to say that that's x1, x2, y1, y2. I'm going to use this formula. So m equals to, now y2 is this one over there. So negative 3 minus y1, which is this one over here. 6 divided by x2, which is this one over here. 1 minus x1, which is this one over there. Negative 3. And I get negative 9 over 1 minus 3, which is 4, which is the same answer. And that applies to any 2 points. So you can use that formula, or you can use the original drawing the triangle. That's up to you. But if you want to be right every single time, you should probably go with the formula. It's a little bit clearer, but that's up to you. So you identify one as x1, y1, and then my second one as x2, y2, and then you use the formula. Okay, let me know if you have any questions. Otherwise, good luck.